Okay, so we're going to wait a few moments because last time we started with a joke and apparently it cut it right off. So the start of last week's or 2 weeks ago, the episode is us laughing at a joke that nobody else heard, which just trust us, it was a really, really good joke. It just wasn't recorded. Hey, Glenn, how you doing?
Harold, how are you?
I'm doing fine.
I'm
Doing
recovering
fine.
from a cold.
It seems to be going around this year. I'm
Yes.
very fortunate. I have a wife that drags me to go and get a flu shot every
Oh, I
year.
got my
So,
flu shot. I don't have that.
oh, okay.
I have had friends who had it who literally were like laid up, especially if you have young kids. The one
Yes,
friend I have who it tore through her house. She has, a young daughter, and that's all it takes.
I remember those days of when my daughter
Me
first started
too.
going to school. Well, see,
Me
we work
too.
from home, both me and my wife.
Daddy!
So,
Daddy! Get away from me.
so we have a potpourri of interesting topics on for today. But
Yeah, we're
before we
only
get to that,
yeah,
let's
before we
let's get
get to that.
business over with.
Yeah, well, let's first talk about the fact that we're only 7 minutes late this time. So we're kind of getting better. Maybe next time, let's cut it down by 2 minutes. Let's get to like five minutes late. And
Okay,
if we keep working on it within like 3 sessions, we could actually be on time.
it's a show goal.
Maybe it's a feature that we're not on time. And that's
No,
one of the things that differentiates us is the fact that we're generally not on time.
no, I don't think
That
so.
doesn't, I can't sell that.
No.
I'm trying. We're working on my salesman skills.
So let's you have an awesome new jingle. I want to hear your new jingle again. Let's see if you can do it as well as you did in practice.
It's not really like a jingle, but okay.
What do you
Well,
call it
before
then?
we get started, we want to thank our sponsor, Auth0 Extend. Auth0 Extend is an embedded SaaS customization platform. With Extend, your sales engineers, customers, and partners can tailor your SaaS and create custom integrations right from within the product. There's no hosting, no servers, just code. You can find out more at auth0.com/extend. How was that?
That was just fabulous. Now I have to do my my pattern of the week, and I went and clicked on completely the wrong button there. I clicked on cameraman, and I meant to click on this screen share button. So I'm going to be really lazy this week and pick a really easy pattern. This is the pattern which I called the factory pattern, and it's pretty much the one that most people are used to in a certain form, which is when we have a collection of things, so slash messages, and we post to slash messages. Generally, the reason we do that is we you can also create things in HTTP using a put, but you need to know the resource identifier in order to know where to put it. So if there's certain server work that needs to go on in order to be able to create something, like, for example, creating some kind of identifier, then you can use a pattern, a factory, to do that work for you. And some of that work might be creating that identifier. So if you do a post to a slash messages, or in this example that I have on the screen here, slash foo factory, then it's going to return you a 201 created with a location header that points to the thing that you just created. Now, we usually do this for collections, and the new resource that gets created ends up living structurally underneath the factory or the collection, but that isn't necessarily the case. You can use factory objects or factory resources throughout your API, and it's not necessary that the resource that gets created live underneath that factory resource, which is why we have the location header to tell you where it is actually created. So that's a really simple one. And one of the things that I realized about this whole series of patterns that I've been meaning to clean up and make a little bit prettier is I'm missing some things here. So one of the things that I'm hoping to add fairly soon is an open API description of the particular interaction pattern and some sample code, which will probably end up being ASP.NET Core. So it'll give me an opportunity to learn a little bit more about writing APIs in ASP.NET Core. So look out for those enhancements to the pattern pages. And if anybody has any suggestions for other patterns that aren't included in the list, I would love to hear it.
So this is interesting, because really what you're showing, I mean, pretty much every time I've done creation, I've generally used post, not put. I'm curious in the wild, how common is put, where you use a named, because the big distinction, and I think a lot of people don't get this, is the fact that with post, the server creates the resource, gives it the name, whereas in put, you're actually naming the resource at the time, and you could be either creating or updating. I'm curious in the wild how common using put for creation actually is.
It's actually very common. I know when I was at RunScope, the RunScope APIs all use put explicitly.
Okay.
And if you look at Azure Management APIs, in order to enable deployment templates, which are used to basically documents to create a whole bunch of resources at once, they all use put, and they use the put specifically for its idempotency characteristics.
Right.
So
you
the
can
idempotency
being,
if it failed the first time, well, you can just send the same message again and again and again, and you'll not generate multiple copies of said thing.
Right. Right. No, I mean, I guess one thing that you're showing here that is different is the idea of having a dedicated factory resource, which is separate from, I mean, sometimes the parent resource gets used as that factory, so to speak, right? Like, let's say you have like orders. What I generally have done is I would do a post to orders. It would act as that factory, but nothing stops. I mean, URIs are just, identifiers. So nothing stops doing what you just did. But I did find that interesting that you kind of identified a factory resource very clearly. And I guess I can see where that would come in nicely too. I'll just get this thought out. Where, you might have like a get to orders gets the order. Would you see a situation of where I might have like an orders resource that I can post to, or the factory? Because often when you have a factory, in some cases, like when we think about it from a programmatic perspective, there are some places where the factory is absolutely required and you cannot just new up, and I'm just bringing object oriented. I know I'm being blasphemous.
No, you follow the same patterns.
You can't just new up the object. And then there's other patterns where I guess it's closer to more the builder pattern, of where
absolutely,
you could new up the object, or you could use the builder, which does a bunch of convenient things for you. Do you think there's an analogous to that pattern in the web, of where you would say, oh, there are situations where I might want to use the factory resource, but if I want to, I could actually just post, directly, and maybe some of those extra things that happen wouldn't happen.
So if on my patterns index page here, let me just show it again.
Yep.
So one of the ones that I haven't finished, right, is what called builder. So a builder resource is like a factory resource, and that is used to create another resource. However, the builder is a transient resource that enables idempotent creation and allows the client to specify values that cannot change over the lifetime of the created resource. So what you do is you create, you basically do put to one place that ends up creating a resource somewhere else. Anyway, I will go into that in more details.
Okay, cool.
But I called out specifically. There's a number of things that we do in object-oriented design that map fairly cleanly over to the HTTP world. And as you said, most of us use collections to also act as a factory. But it's interesting to recognize that it is a distinct trait. and they two can be separated. You can use a collection to be a factory, and you can have a factory that doesn't necessarily implement the get. So you can create something, but then not be able to get a list of those things afterwards, right?
Yeah.
Just depends on the scenario.
Yeah, cool.
So that is our conversation about patents for the week.
Yeah, I do want to say that I think showing the web page was nice.
Yes, it will be sad for all those folks who are using the RSS feed. They won't get to see those extra pages, but if they're really interested, they can always come back to the YouTube video and take a look at that later.
Just make sure you put the link into the blog post that doesn't exist when it finally exists.
Well, we have our Twitter account they can follow. We post the links in the Twitter. We have the Slack channel that you can also go to that I believe is linked from the profile of the Twitter account. So hopefully we are discoverable in some way or another.
Hopefully.
Right. So, which brings us to let's pick up the topic that we didn't get a chance to finish last week, or didn't get a chance to even start last week because we talked for too long. I'm going to talk a little bit about the theory of persistent connections. There's a lot of real actual implementation issues that kind of follow on to this, but I want to start with a little bit of a theory rant because those are the things I love the best. So persistent connections, they were introduced in HTTP 1.1.
Mm-hmm.
In 1.0, many years ago, when you made an HTTP request, it would open an underlying TCP connection, it would send the stuff off, you would get the response, and it would close it immediately.
Yep.
And people discovered that wasn't a great idea, because often when you make one call to a server, you're probably going to make another call to the server right after. So they played around with this notion of a thing called a keep alive header, which was an indication to the server, please don't close this connection. And that keep alive identifier, I don't actually think it made it into any official spec. It was just one of those things that implementers realized, hey, this is a problem. We need to fix it. How are we going to fix it? Okay, let's do this. So then when they came to writing HTTP 1.1, they went, yeah, we definitely, this keep alive header has been a really good thing. But you know what? From usage analytics, this is what we want to really do by default. So they made it a default. So the keep alive header never made it into the 1.1 spec. What ended up happening is that became the default behavior. And if you wanted the opposite behavior, you use the connection header and you said connection close. Now you could do that either way. You could either, the client could say, I'm sending a request and I'm sending a request and I would like you to return back the response and then close immediately. Or it could be the other way. I could send a request to the server and the server can say, yeah, I'm going to send you this response back and I'm going to close immediately.
Yep.
Okay. But there is no more keep alive header. Funnily enough, because of the reality of the web, keep alive is everywhere. Like almost every server that you see returns this mysterious keep alive header that really in reality should have only existed for like the year and a half between the time of its introduction and the introduction of persistent connections. But it still exists today and people still insist on putting it. But really, you should only ever use it if you are knowing that you are talking to a 1.0, HTTP 1.0 service.
Yep.
Okay. So that kind of gets that over the way. So now we know that when we make requests, connections stay alive, which is a good thing because it's more performant, and it's even more important these days because we're using HTTPS. So the connection setup is even more expensive these days. So tearing down connections and reopening them is like even more expensive. And now we have HTTP 2. And HTTP 2 can not only reuse connections, it can also multiplex over connections. So it is even more efficient at using connections. And it has header compression. It uses HBAC header compression, which gets set up, and the tables that are used in order to send basically shortcuts for headers across the wire only live for as long as the connection.
Well,
So
the
if
headers are now binary, right?
well,
In
they're
HTTP2.
well, yeah, but the values, the header names, certainly common header names are tokenized.
Yeah.
And it can even tokenize the actual values.
Values.
So
Yep.
if you're sending the same value to the same server over and over again,
Send a
it will
token.
just send a token. It will do a lookup in a table because both the client and the server have to build these
Sure.
correlated tables
Yep.
as you send requests over the connection. So the more you use that connection, the more efficient those tables can get. But you
Yep.
tear down a connection, those tables go away.
Yep. Makes
So
sense.
there is huge value in order to maintain
The
the
connection.
connections, which brings us to the problem of persistent connections. And this is a problem that I've seen pop up in numerous different areas, which is where you have servers sitting in the cloud, for example, and you are doing, let's say you have a failure scenario, and you've got servers sitting behind a load balancer, and one of those servers fails and starts returning invalid values,
Right.
and you've
Because it
got
doesn't have the token. It doesn't know, because it no longer has that lookup of the tokens, but the client's still sending the tokens.
well, no, it's not that. It's, let's say there was some kind of application error. I don't know,
Okay.
the server ran out of disk space, right? Or
Gotcha.
something that's causing that server, when you make a request, to send an invalid one. So normally in a failure scenario, you should switch over to the other load balancer. But what happens if that server is returning status codes and there isn't a recognition that it's a failure, and that connection stays open, and you're just going to keep sending to that same one? The other scenario, which is probably a better scenario to explain, is when you're doing like a slot swap for a deployment upgrade. We have the v1.004 version of our API, and we want to roll out the 1.005, and we put 005 in place, and we do a swap to say, okay, now let's roll 005 out into production. But because of this persistent connection that's open with the 004, requests keep getting routed there. So people end up getting stuck on this old server, and as the connection will get dropped after a period of time of inactivity. But if the server's constantly being hit with requests, then that period of inactivity never happens. And there are a number of techniques that people have kind of developed, because there's no official way of fixing this per the HTTP specification. So some people have implemented this kind of what's called a least timeout, where even if there is activity after this period of time, just boom, kill the connection.
Yeah.
I've seen other solutions where people have said, look, no matter what, after 15 minutes of calls, let's just open a new connection, and all new requests are going to go over this new connection. So just periodically start using a new connection. Even if we could use the existing connection, let's not, just in case something has switched behind the scenes. And
I have a question.
Yep.
Just to clarify. So you mentioned this idea of like a token cache, which obviously has to be shared, which is on the client and the server. So are HTTP clients and servers now being implemented for HTTP2 such that every time there's a connection, these caches are automatically created, and when the connection dies, those caches automatically get cleaned? Is that
okay?
Is that a simplistic?
That's my understanding. I've attempted to read the HPAC spec, and it's fairly impenetrable. I've read it multiple times, and that's the understanding that I've got. I think it's one of those things where you actually have to implement an HTTP2 server and client before you fully understand how it actually works. I'm sure there's people out there who can tell me really how it should work. But
Okay.
that's my understanding of how header compression works. Is it builds these corresponding tables on client and server, and there's a whole kind of protocol that goes on behind the scenes saying, oh, by the way, I've added this to
Like
this.
a handshaking.
Yes, I believe so. And as I say, it's been a little while since I've read into it, but there's definitely a responsibility of client and server to build these tables so that they can communicate with those values. And it's interesting. It's possible that at some point somebody might come up with some kind of optimization to make those tables last longer than connections.
Well, I was wondering if they're predefined.
There are certain predefined values. Yes, for common standard headers, there are some predefined head name tokens. Obviously, value tokens make less sense because most of the values are actually unique. But yes.
Cool.
So the one extra part of that whole connections challenge is, like, let's say even if we do break that connection, we still, and then we say, okay, well, we're going to reestablish a connection, and hopefully we'll now point to the new server that has the new version of our API. We still have to live within the constraints of DNS lookup. And if we happen to kill the connection and then do a DNS lookup, but the time to live of the DNS has not switched over, you might still end up getting connected to the old server rather than the new server. Now, it depends on how that load balancer works and whether it does it via changing IP addresses or whether it has these notions of virtual IP addresses. This is, again, it's a level of networking that goes beyond my detailed understanding, but there is basically the keeping connections alive through constant usage. You got to break that connection, then you got to make sure that if you need a different DNS, that the DNS has expired. So you got to be careful of how long those TTL values are on DNS.
So I've got another question. So, like, one of the big uses of persistent connections in the last number of years has been around WebSockets. And there's been a lot of talk about how, with the advent of HTTP2, that, like, WebSockets is no longer as critical.
Yeah.
Do you have any thoughts on that? Or do you feel like HTTP2 is addressing a lot of the concerns? I mean, one of the things people say is that, like, because HTTP2 has push, like, one of the big magic things about WebSockets is that bidirectional, that ability to have the server push and notify when certain types of events and things happen. I'm just curious what your thoughts, and the only reason I'm bringing it up is related to the persistent connection.
Sure, absolutely. And yeah, there are a variety of ways of sort of making HTTP do more than just request response, right? I certainly don't think server push is a direct answer to things that need to do WebSockets today. I think a better answer is the fact that you can multiplex connection requests so that you can actually send a request body in chunks and start actually getting responses in chunks back while still sending the requests in chunks. So you can have fragments of a request going whilst getting fragments of a response coming back. And that makes it a lot easier to implement the long polling type scenarios. WebSockets takes things to a whole other level and sort of gives you this clean slate to say, yeah, the way HTTP defines its messages is not the most efficient for me, so therefore I want to do things a different way.
Yeah.
It's a very much, I want to get back to the basics, and I think there's probably some scenarios that could call for WebSockets. I think there's a lot less than there used to be. but I think there still are some, and I have seen work ongoing about enabling WebSockets over HTTP 2, because currently you can't. I don't think you can kind of upgrade from an HTTP 2 connection to a WebSocket like you can. So there's currently work ongoing to enable that within the IETF. So I don't think WebSockets is going to go away. I don't think it handles all scenarios. I think just the scenarios that it's needed for are a lot less than it used to be if we use HTTP2 correctly, which again is another big.
We have a question from the community. What are some detriments to using keep alive persistent connections on my HTTP requests? And thank you, Tim, for that question. I know this opens a can of worms. Go for it, Daryl. Rant.
No, I'm there. With every option, there are always drawbacks. I'm just drawing blanks at the moment.
Well, I can give one. I think that's always been raised is the fact that it's using up server resource. Each persistent connection is using up memory on the server. Memory nowadays is cheap.
Yep.
So there's that problem. The other problem is you could have starvation of sockets because of the fact that each persistent connection is using a socket, particularly if you think about like a high volume with, millions of clients.
Yep.
You can totally starve out because there are, depending on the OS, there are limitations. And a lot of people just don't realize that each socket takes memory. So, you don't have an unlimited pool there.
Yeah.
I mean, you can add additional servers, you can build something out that's scalable, and some of the load balancers, I think load balancers are really key here because you ideally don't want the client to have to know about the different servers that are there, but you want to be able to scale out. And so load balancers like Nginx, for example, can support WebSocket traffic.
Yeah, I think the other thing to recognize is this whole conversation about persistent connections is only relevant per hop. So what I mean is that you have some client, you're sitting at your desk in a corporate business and you're making a request to some server that's at the other side of the world. You're making a connection possibly to your outbound proxy server. That outbound proxy server is making a connection to some front end proxy server that lives in the ISP of the service that you're calling, which is then making a connection to the backend server. So we actually have three different connections going on there that we have to talk about the lifetime of each one of those. To a certain extent, it's a different conversation for each one of them.
Right, and then there's costs associated. You're using up more resource across all those different places, and the bottlenecks can exist in multiple places. And the more hops you introduce, the more possibilities of where the weakest link, any weak link across that chain of hops is going to kill the connection.
Yeah, and let's say you do persistent connections, and you say this is wonderful and we get all kinds of performance benefits of it, and then you decide, well, for some reason you need to geo-distribute or shard certain pieces of your infrastructure. Well, a persistent connection only exists with one server, right? So now you are going across multiples. You'll need a connection to each one of those servers, effectively. So it's a lot more complicated than it sounds in theory.
Yep. So I guess that's probably the other challenge, is the fact that there's a lot more machinery that's coming into play that you're just relying on. So there's a bit of a magic aspect there, but it's really not magical. There's a lot of dots that need to connect to make that work.
So the funny thing is both you and I have probably told people 100 times that HTTP stands for Hypertext Transfer Protocol, not Hypertext Transport Protocol, because HTTP is an application protocol.
Yes.
But all these things that we're discussing, they're not application issues, they are transport issues. And HTTP was supposed to abstract that away so that we didn't have to think about these things, but it didn't quite do what it was supposed to do. So yeah, so here we are.
Well,
having
this is
to
why we
live.
had things like, WCF. That made that problem go away.
Yes, absolutely. It made that problem go away, and it introduced a whole bunch of new problems.
Come
So
on, Daryl. It made that problem go away. Let's just say it made that problem go away and move on.
yes, yes.
Hey, at least we didn't mention that other thing.
Well, that's coming up soon. Don't
Oh, that
worry.
is true.
Don't worry.
Yeah.
Don't worry. Okay, so while we are talking about transport versus application protocol things, that segues quite nicely into the other thing that I wanted to talk about. And I'm only going to talk about this briefly because I didn't have enough time to dig into it as much as I really wanted to. But I want to talk about the content encoding header and transfer encoding.
Mm-hmm.
So people probably are, if anybody's familiar with transfer encoding, they're probably familiar with it because of chunked encoding. If you've ever used chunked encoding, and people are probably familiar with content encoding because of things like gzip and
Why don't we give
deflate.
Do you want to give a quick definition of chunked encoding? Just a very short sentence.
Ooh, that's a tough one. So chunked encoding is where you make a request to this. Well, let's do it on the response. So we're saying to the server,
because you can do either way.
Yeah, let's say I say to the server, I understand chunked encoding. In fact, if you're HTTP 1.1, you have to understand chunked encoding. That's one of the rules. So you say to the server, I would like this response. And the server says, I'm going to send you this response, but I only have part of it ready yet. So I'm only going to send you some of it. So I can't send you a content length header.
Right.
So what I'm going to do is I'm going to send you a few bytes, and then I'm going to do a new line, carriage return line feed, and I'm going to tell you how many bytes that I sent you. Does it do it that way around? No, actually, it does it the other way around. It says, I'm going to tell you how many bytes I'm going to send you, and then it sends you that number of bytes.
Yep.
And the client can go, oh, you told me, you didn't give me a content length header. Right. You told me you were sending it chunked encoding. I see this first line has a number in it. Well, that number must mean how many bytes that you sent me. So you sent me 34 bytes. So I'm going to read 34 bytes from the stream.
Yep.
And then I'm going to sit and wait. And then the server is going to send you another number, which is 74, and then send you 74 bytes. And this repeats ad infinitum until finally the server says, okay, I'm done sending you all the bytes. So I'm now going to send you a 0. And the client is going to receive the 0 and go, oh, there are no more bytes. I guess we're done. I've got the whole payload.
And this has been used as a form of server push in some systems in the past.
Yes, it's definitely been used as a way of doing.
Not that it was designed for that.
No, but it's sort of one of the options of long polling, and I get confused with exactly how people name long polling in a bunch of different ways. There's a few different techniques.
Yeah. The heck is it called? Comet.
There's one way where the client makes a request, it gets this bunch of chunks as a response, and then it closes the request, and then it sends another request waiting for the response.
Polling. Yeah, that's
and then there's another way of doing it where you basically just keep the connection open and just sit listening for these chunks to come back to you.
Right.
Yeah, and I think server sent events kind of works over that same kind of model. Yeah. So that's chunked encoding. And again, remember, this is a transfer level concept. So it works hop to hop, point to point. So the upstream server might have the thing completely buffered from the origin server, but you're just doing chunked encoding between you and it, right? So that's transfer level. Content level encoding says, I did something to the payload, right? And in this case, gzip is the most common content encoding. So what happens is on the server side, you're returning a response. You go, wow, this is a big response. So how about we'll compress it to make it smaller? So you compress it and you add a content encoding gzip header in the
Isn't
response.
that's normally done based on content negotiation where the client sends an accept gzip
Yes.
header, but nothing
Yeah.
requires the server to do that, right? The server could just decide to always be sending, or is it generally expected that the client would send the accept header to tell the server, I can support this,
Yeah.
and you shouldn't give it to me otherwise?
I think it's polite to
Yeah.
let the client tell you that they accept it before you send it down.
Yeah.
The spec doesn't do that, doesn't must. Like none of
Right.
the
It's not a
accepts or must.
Right.
The server can do whatever the hell it
But
wants.
that's a common protocol. And I'm only really saying that for people that are listening who may not be familiar with how this works. To give you an example, when I was at Splunk, one of the efforts that I led is we had this HTTP event collector, which was a way to actually you can do the client side as well, which is the sending. And in that case, we were doing it for sending. We were allowing clients to send. So in that case, they didn't do the accept header. They just sent using the encoding, the gzip encoding header to tell the server that, hey, I'm sending you information that is gzip encoded.
Yeah, there must be a way for a server to say, yes, I understand gzip. It's probably some kind of options thing.
Options.
Yeah.
I think you can indicate that in options. Yeah.
Yeah. So the interesting part of the whole content encoding thing is it's a separate header from the content type.
Yeah.
So we have a content type that says, I'm returning you back.
Sure.
JSON LD. All right.
Yeah.
So application/JSON LD. But the server says, this is a big JSON LD document. I want to compress it. So the results are compressed.
Not encrypted, compressed. Sorry.
Yeah. So they're compressed. So what is actually coming back over the wire is not actually JSON LD, or it certainly doesn't look like it.
It's JSON LD.
Right. So you have to first look at the content encoding.
Yes.
And unzip it. And then you can actually look at the type. Yes. But the interesting thing is intermediaries along the way, along that path, can look at the headers and go, oh, I happen to know that this is JSON LD that's passing over the wire. Even though if they tried to sniff it, they would not see JSON LD. So this is it's an important distinction. And the reason why I'm getting to this is because the conversation came up over the last few days within OpenAPI conversations about adding encryption and signature support within OpenAPI. And there are various efforts out there in order to be able to take a payload and encrypt it. And this is especially important in Europe at the moment with all this PSD2 effort, which one day we'll get into actually having a conversation about APIs and banking and finance. But obviously, secure and encrypted transactions are something that are very important to banks. And so once you start to want to encrypt the content, you could use this notion of content encoding to say, oh, by the way, here's my payload. It's JSON LD, but I've applied on top of that a content encoding, which you're going to have to decode before you actually see the JSON LD. And some of the efforts that I've seen while starting to dig into this, they've taken the approach of, no, we are going to change the payload completely. They've created a new media type, which specifically says this is and I'll use one particular example, a JOSI, which it's related to JWT tokens. And that standard has a media type called application/JOSI, and it is an encrypted payload. But they use the content type. And in doing so, you've obscured what the actual semantics are of the message that has been sent over the wire. So in choosing to use not the intended way of doing it, not using content encoding, we lose a little piece of information in that transfer over the wire. So that's the cool thing about content encoding. And one last comment is about transfer encoding, because for compression, using content encoding is not the only way. You can also use the transfer encoding, which we talked about for chunked. You can also gzip. And in the same way that you can send an accept encoding header, a client can say, I understand how to ungzip things using accept encoding. You can also send a TE header that says, I know how to do gzip transfer encoding. And when a message comes across the wire, then you can automatically gzip it. Now, the difference is this is at the transfer level, so it's only hop to hop. So, for example, I'm sitting in my corporate network making a request to my proxy server. My proxy server makes a request out to some front-end server, which then goes to an origin server. The origin server may send the response completely uncompressed. The front-end server may go, hey, I know how to compress this stuff, compress it on the fly, send it down to the proxy server. The proxy server goes, oh, I know how to decompress this, decompress it, and get it at the client side. The client may get the result completely decompressed and have no recognition that it was actually compressed for one of those hops over the wire. Now, apparently, transfer encoding is not implemented in anywhere near as many tools as it really should be, and it isn't used a whole lot. So but it is definitely another option that's out there if the tooling that you're using supports it.
Yeah. What I found interesting about this too is, HTTP has so many rich semantics that we always talk about. One of the benefits of playing by the rules is you get to benefit from all that middleware and infrastructure and proxies and all
Yep.
those things that are out there. And this is one of the big criticisms against things like SOAP and tunneling and things like that. And I think even with WebSockets, there's some, because often there's a lot of tunneling that goes on in WebSockets. Yep. People create their own protocols, and you just lose a lot of these benefits that you get, when you do things like what we're talking about, where you're giving these extra hints that servers can use to optimize the payload automatically for you. You may not even see it,
yes,
but it's happening.
Yeah, absolutely. Which just segues quite fabulously into my last conversation of the day, which is to bring back the topic, the name that previously shall not be mentioned, but today we are making an exception. I'd like to talk about GraphQL.
This is blasphemous. We need like a Voldemort, something with graphic, or some physical thing that we could just bring up. It's time.
It's time. That time of the show where we talk about GraphQL.
Excited to hear that you have finally bought in, Daryl.
Well, I was so excited to hear that the GraphQL people had realized that there was some value to the REST constraints.
Why don't we do sharing? Why don't you show that link that I threw in?
Yeah, okay. Chat right over here. Let me click on that link. Dun, dun, dun. Okay. So
you're not sharing.
I know. I'm getting there. I'm forming my thoughts. So I actually watched a video about this from a member of the Relay team, and because they were talking about their years of experience at working on clients for Facebook.
We should mention what Relay is.
Oh, I have no idea what Relay is.
Relay is a client. So when you're doing GraphQL, so one of the things we've talked a lot about how GraphQL has this ecosystem of libraries. And Relay is a GraphQL client.
Oh, okay, cool. That makes a lot more sense. So this Relay is a project run by Facebook, right?
Yep. Okay. So Apollo has their own client as well. So those are kind of the two major GraphQL clients.
Okay, so this person, and I'll share the link to the video also, was talking about the things that they had learned over the years building clients for Facebook GraphQL using for both Android and iOS.
Yep. And he works at Meteor, which Meteor actually creates the Apollo client, that is the other GraphQL client that I was just mentioning.
Okay. So one of my criticisms in the past of GraphQL is that because when they're making queries, we're using a post method and putting the query in the body, we lose a lot of the ability to do caching, first of all, because you're doing a post, and second of all, because you're allowing a client to construct the query, you don't know in advance what the wide range of many, many queries might be. Therefore, it's hard to put an identifier on it and keep a cache of the result. You're going to end up with a very diluted cache because every client's going to ask a slight variant of the requests. And generally, the solution to a lot of the problems that the GraphQL creators described when they explain the benefits of GraphQL is usually solved in the REST world by, well, just create a new resource to handle that specific scenario. And the argument has been in the past that, well, we want clients to be able to design those things. Fair enough. That's comes a bit more of a Conway law thing rather than a technology problem, but okay. So in watching this video talking about GraphQL, one of the things that I learned that they've created is this notion of persisted GraphQL queries, because the point was made that it's actually expensive on the client to construct these complex queries, process them, parse them, and then send those bytes up over the wire of a large query when you're making the same request over and over again from that mobile client. So the optimization was, well, let's take this query and we will store it over in the server and give it an identifier. So then all we need to do is pass an identifier up and the parameters, and we effectively have either what you'd call in the database world a stored procedure, or in the REST world, it's just another resource with some query parameters. So we've finally converged on a similar solution, and then that enables you to actually cache results to those persisted GraphQL queries. And it's cool that you bring up the fact that now the Apollo client is doing the same kind of thing, having this notion of persisted GraphQL queries.
Were the first to actually do it.
Oh, okay.
If you look at this article, this was in February of 2017. That in terms of first to bake it in into the client. I don't know if they were the first to do it. I do want to mention one thing, though. I think we're on to another HTTP pattern here, because this is definitely not something that applies just to GraphQL. So
I did this in REST. I did exactly the same thing.
Yeah, because I've also done this in places where things that would have normally been persisted on the client, like session state, you can also use resources to do this. So back in the day, now this was all just a made-up thing, but there was you'll probably remember this, Daryl. There was this project I was working on, which was called like REST Cart, which was like a shopping cart kind of experience, REST-based. And, it was trying to be like an example of illustrating. And one of the things that is common with a shopping cart in implementations, it was very common to just be like, oh, well, this is a great place where we use session state. And, based on that session ID, we can then get that shopping cart back.
Yep.
And so I had been exploring the idea in REST cart of having the shopping cart be a resource. So it's a transient resource that's probably not going to live around for a long time, but it gets rid of the notion of the session state, or it is kind of a session state, but it's not something that is opaque. I guess that's the big difference, because session is generally something that's completely opaque.
Yeah.
So
and as soon as you make a resource and give it an identifier, it's no longer opaque, right?
Exactly. And then that resource could get destroyed later. If it's a transient resource, there could be some cleanup on the back end that suddenly that resource goes away. But I think this pattern of turning a query into a resource is something that's super useful, whether you're doing GraphQL or not.
So I have one last very quick comment, and this sort of was triggered by a friend of mine, Gareth Jones, who's an API guy at Microsoft. And he made the comment that, over the last bunch of years, we've transitioned into kind of the self-service API world, where in order to start using an API, you just basically walk up to a portal and you get a key and you can all of a sudden start using it. So that authentication process is self-service. And he said we could be moving to a much more self-service kind of query world and resource creation. So now you walk up to an API and it gives you the ability to pre-create the resources that you need for your application, your client application.
Right.
So you craft the query in GraphQL,
Yeah.
and then you store it on the API server, and then from your client application, you call that. So now you are in control of that query. But we've solved the problem of caching, and
Yep.
the server side, the API provider can start to analyze these queries and say, look, these are the queries that our customers are creating. How do we optimize these experiences? They can get analytics, they can do diagnostics, they can go, oh, wait, that person's doing a query that's really weird.
Well, they can also schedule them. So like when I was at, I was at Splunk, one of the big things that differentiated Splunk as a platform is it has these ability to do these things called saved searches. And saved searches are searches where they run on a frequency in the background. And they were really important for big companies like Walmart that were using Splunk, that were running at like massive scale. But these reports needed to be fairly up to date. But it could be that they were up to date only within 30 seconds, which was often more than enough to service the needs and to get the, because the accuracy of the data may not need to be within a second, or even if it was within a second versus milliseconds, that can make a huge difference. So this is why I think if you haven't documented this pattern, it's interesting to document it and to go into the scheduling aspect, because as the client, and you can also use HTTP headers to tell, I forget which header you could use, but you could communicate that this is accurate as of blah. So for reporting, this ability to have clients to be able to define these kind of saved queries that they can run, and then behind the scenes doing those optimizations, not only from an analytics perspective, which of course you could do, but also getting those benefits of caching the results and refreshing them on a certain schedule. Super powerful. So maybe you can
that's really cool.
Document that if you haven't done that.
Well, I have a pattern that's very similar, and it covers this topic. It's called the bouncer pattern.
Okay.
So we'll talk about the bouncer next week.
Perfect.
And we can continue this conversation then.
Awesome. But this was great session today.
Brings us to the end of our time. Thank you very much, Glenn, and we will talk again in 2 weeks' time.
Looking forward to it, Daryl.
Bye.